Hey guys, Mr. Butts here. I want to take a look at an infinite series that kind of looks like one of the Maclaurin polynomials that we've been working with. And it doesn't have any x values in it, so it's actually a numeric series. And we want to figure out what is the exact value of the sum of the infinite series. So first thing I'm going to do is try to figure out what function the series is representing. So I'm going to take all of these twos here that look like they were probably plugged in for x's, and I'm going to replace those with x's. So the series that we're going to look at right here is going to be x plus x squared plus x cubed over 2 factorial plus x to the fourth over 3 factorial plus x to the fifth over 4 factorial. And then we're going to have x to the n plus 1 over n factorial. So this is really, really close to a Maclaurin series that we know, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. The difference here is that the exponents are not matching up with the factorials in the denominator. So what I can do here to make it look like this one is just factor out an x. So if we take this entire series and factor out an x, we get x times 1 plus x squared over 2 factorial. And I'm not going to write out all the terms because you can see the pattern here. That gives us x to the n over n factorial for our general term. And so now we have part of this that is a series that we know. And we know that this is equal to e to the x. So this function then, this whole thing is equal to x times e to the x. So what that means is that this right here, this whole thing is going to equal, instead of x, we have 2's in there, so that's going to equal 2 times e squared. And that's our answer. So we took this series that it was a power series, but then has a particular value plugged in for it. So we figure out what power series or what function that power series represents. We have to be careful and make sure it represents it exactly. So we might have to do a little bit of manipulation. In this case, I was able to factor out an x so that we could match it up with that e to the x power series that we know.